Hello and welcome to this CPD short from Complete Maths, and this time we're going to be looking at the sum of the interior angles of a polygon. And whenever I'm teaching this sequence of lessons, at some point I like to split screen my visualizer and show two different methods side by side. So on the left is probably the more common method that people use, where a vertex is chosen on the polygon and you join two different vertices to make as many different triangles as you can. So you can see I can join to this vertex here and to this vertex here, and I can form three different triangles. You can see I can't make a triangle by joining to this one or this one, so there's two vertices which I can't join to, which is where the -2 comes from in the formula. So in this particular case I can make three triangles, each one's worth 180, so it's 5 sides minus the two vertices that I can't join to, which is my three triangles, and multiply that by 180. And of course I can generalize this result. Instead of having 5 sides I could have n sides, so that generalizes to n minus 2 multiplied by 180. And that's probably the most common method that you see. Sometimes I find that kids can sometimes get confused and just start joining every vertex to every vertex and form loads of triangles. So I do like to show this other alternative method as well. And this one relies on just putting a point somewhere in the middle of the shape, and you join a line to every vertex in the shape. So if it's got 5 sides, you'll make 5 triangles. So 1, 2, 3, 4, and 5. So there's no room to go wrong here in terms of accidentally creating additional triangles. It's just a point in near the centre and join to each vertex. So I can make 5 triangles. So that's going to be 5 lots of 180. But then you need to realise that these angles around this central point here are not interior angles, so they don't need to be counted. So I need to subtract 360 from my total. And again, this one can be generalised by replacing the 5 with n. So you'll get 180 lots of n minus 360. And if you've done factorising with your class, then a nice little link at the end is that you can factorise this result here, take your factor of 180 out, and show that it's the same as 180 multiplied by n minus 2. So there's two different methods showing the sum of the interior angles of a polygon. If you've got any comments or if you got any other methods for this, then please do post in the thread below.